Good afternoon. I hope I am audible to everyone. If there is any problem, please do write in the comments. Okay. Now we are going to start with Core Mathematics 1, that is our CM1 subject. Okay. Now at any point, if you have any questions, you can type it in the chat or you can unmute yourself and ask question. Okay. So don't hesitate to ask any questions. I am Pranay Sharma and I've been associated with S.MONK for past 5 years. Been teaching CM1 and CS1 for past 5 years. Okay, and I'll be teaching you CM1. Okay. So first of all, we'll go through the course. So in our course, there are 27 chapters. Now here in this list, you will find that we have 28 chapters because the first chapter has been removed from the course. So this is not part of our course anymore. Other than that, we have 27 chapters. Okay. In this, first 2 chapters are theory that we'll do later at the end because it talks about everything that we are going to study throughout the course. So it's better to study them one by one and then talk about it at the end. Okay. Then from 4 to 9, these are basics of financial mathematics. We are going to study financial mathematics right from simple interest and compound interest, and we'll go into how we use the interest rates and other financial tools to figure out whether we should invest in a particular project, whether we should run a particular project, how much are we going to earn. Everything we are going to see throughout this particular course. Then from 10 to 14, rather 10 is just it's not even we'll call it as a chapter, it's basically just a transition from 9 to 11, so it's nothing. Okay, from 11 to 14 is the application. This is where we learn how do we apply our concepts to loan, how do we apply our concepts to understand whether a project should be taken into consideration, how do we value bonds, equity and property and other stuff. Okay, and what happens if rate of interest keeps on changing, that is our term structure of interest rate, how do we manage that. So these are all applications of everything that we are going to study from chapter 4 to 9. Almost in every course you are going to find the same thing, that we learn the basics first and then we have few chapters of application. So even though it may feel like we are going a little bit slow towards while we are studying the basics, it is necessary because understanding the concepts is the most important part when it comes to basics. In application, then solving sums is more important because the concepts in application are very simple. We don't have a lot difficulty in understanding the application part. But if you have any issues in the basic part, then it becomes difficult for us to apply that in later. Now after this, from chapter 15, we have life insurance. So this used to be 2 different subjects. Now they have combined into one, financial mathematics and life insurance. Okay. So from chapter 15 to chapter 28, we have life insurance. Okay. Now again, when it comes to life insurance, we'll have some basics at the beginning. So from chapter 15 to chapter 19, rather chapter 15 to chapter 18, we have basics. And from chapter 19 to chapter 25, we have, you might say advanced. This is not basics. Okay. Advanced level of life insurance part, and this is sort of the application part. Rather, we should not be dividing it into application because This advanced part is also application. This is just working. Okay. Okay. So instead of advanced, let's write working. This is where we understand how a life insurance company works. And this is profit testing. Every company's aim is to earn profit, right? So throughout this course, we are going to see that for a non-life company, this is for non-life, general company, how do we determine how much profit can we earn? And this is for life insurance. Again, we want to check how much profit can we earn. Okay, so throughout this course, you will understand how we determine or how we value a financial asset. Okay, that is all here. And how does a life insurance company work and calculate their profits? That is going to be here. Today we are going to start with chapter 4. Okay, so again, chapter 1 is not part of our course. Chapter 2 and 3 we'll do it at the end. So theory chapters. So we are going to start from chapter 4. The chapter 4 name is time value of money. Now I would like students to also participate. So I'll ask few questions. If you feel like you can write it in the chat, you can unmute yourself to answer. Okay, everything is fine. So when we say value of money, okay, first of all, forget about value also. What is money? When I say money, what comes into your mind?
Mode of exchange.
Yes, mode of exchange, good. Anything else? Anything. Okay. Whenever we are learning, we cannot be wrong. Okay, so even if you are wrong, that means you are learning something new. Okay, so I just want to know, whenever we all use money, we all know what money is. So I want to know, when I say money, what comes into your mind? Okay.
Inflation.
Inflation. Okay, then there is used for buying and selling any type of transaction. Okay, again, mode of exchange or mode of transaction, mode for transaction, let's say. Okay, universal mode of transaction, good. Okay, so money here we are saying is mode for exchange or mode for transaction. Okay, and it is related to inflation. Okay, so inflation, we'll talk about it later, but the other two, yes, money, whenever I say money, it is mode of exchange, it is mode for transaction. Okay, so money is not actually a physical good. Okay, it's not physical. Now you might say that I have money in my wallet, that is definitely physical. Okay, but if you just take a 100 rupee note, just try to search a good picture and I'll show you. Okay, if you I'm trying to find a clear picture of 100 rupee note. Let me just. Here in this 100 rupee note, you will find something written here. Okay, it says, I promise to pay the bearer the sum of 100 rupees. And it is signed by the governor. I hope you can see that. If not, you can see a physical note yourself and you will find the same thing. So it says, I promise to pay the bearer a sum of 100 rupees. So this is not exactly 100 rupees. This is actually a promissory note. You might have studied in law or some other subject what a promissory note is. That means if I write on a piece of paper that I will give you, I promise to give you 200 rupees in 3 days. What does that mean is you will come and you will show me that paper and say promise to pay me 200 rupees. Now where is my 200 rupees? Similarly, this is also just a promissory note. The governor of RBI has promised you to pay the sum of 100 rupees to whoever holds this note. So it's a promissory note. So this is not money. This is just a promise to pay you money. Okay. Now, a few years back, I think before 2005 or something, or 2012, I don't remember perfectly, they used to write that I promise to pay the bearer equal amount of gold worth rupees 100. So before, the currency was related to gold. How much gold does RBI has? That is the amount of money they could print. That is how the money was valued. But now everybody came together, all the countries in the world came together and said we don't want to use gold as the basis for currency. So now it's just an arbitrary asset. So now every currency has been delinked from gold. So people, I don't know how do they value the currency nowadays, exactly how do they realize that this is the amount. But because we believe in the government and the person that you're buying a product from believes in the government, that is why this 100 rupees actually works, right? And that is why government could do demonetization. They said this currency note is not value, or the value of this currency note is nothing now, it's just a piece of paper. So whoever holds that will get nothing. So nobody is ready to take that 2000 rupees note, right? Now I think in a few days 2000 rupee note will also be taken out of circulation, correct? So in that sense, this is just a piece of paper. The only reason we can get any product out of it is because we both believe in the government of India or the RBI. Similarly, if I have $1, I can go and sell it to somebody else. I can take money out of it. I can take goods out of it. I can take service out of it. The reason it would work is because people believe in US government. They promise that $1 is worth that much. So if this physical note is just a promise, what is this 100 rupees? What is this 100 rupees? Can anybody tell me? The money is actually just an concept. Just like mathematics is a concept, money is also just a concept. You might say that we see geometry every single place, but you don't really see algebra anywhere, right? In real life, it is present. Okay, it is part of our life, but you don't see, directly some numbers in physical sense. Correct? What is it? Is just the translation of our understanding of the world. That is mathematics. Similarly, concept, money is just a concept for us to understand how financial world will work. It is concept for mode of exchange. It is concept for mode of transaction, so that we could felicitate exchange, we could felicitate transaction in a better way. It's simply, we all have studied what barter system was, right? Before the money was invented, we had barter system. So let's say a fisherman catches some fishes, a farmer produces wheat, they come together and they exchange their goods. It was very difficult for a fisherman to understand how much time, how much effort does it take to grow wheat. And it was very difficult for a farmer to know how difficult it is to catch a fish. So when they tried to exchange goods, it was difficult for them to value those goods. So they needed a third party so that they could value their own products. So fishermen will say that a one fish is worth 1 kg of wheat. Farmer will say that is very ridiculous. 1 kg of wheat is worth 3 fishes, right? So because they don't understand the value of each other's product, it was difficult for them to exchange that ways. So then came in the third party, that is our money. So the farmer can value their own wheat. They can say 1 kg wheat is worth so and so money, and the fisherman can value their product, their fish, and say 1 fish is worth so and so rupees. So the money was there just to felicitate the exchange, just to felicitate the transaction. That is the main reason money was invented. Now yes, it was 100% just physical coins for a very long time. Physical coins, physical notes. But today we know that most of the money is not in the physical form. Your bank account, the money that is in your bank account is not in the physical form. We all use digital transactions today. We very we at least 50% of the times, or maybe more, we have stopped using physical currency, right? Either we use UPI, Google Pay, Paytm, whatever, or we use debit cards and credit cards. These are all online transactions in which the money is directly transferred from one bank account to the other bank account. It is never physical, and for almost majority of the money, it will never be physical. It will just be numbers in somebody's computer. It will just be numbers. So when I say that physical currency, physical note is not actually money, it is just a promissory note of giving you money. It is just a piece of paper that is easier for us to transact with. And as we have seen in past few years, people prefer doing online transactions rather than having physical money, right? It's just easier, it's more convenient. So maybe in the future we'll not even have physical money. This currency, this note will not even exist. Correct? So money is a concept that is used for exchange, that is used for transactions, or you might say it is used for valuing goods and services. So it's a mode or it's a concept so that we can value goods and services. Okay. And hence comes the value of money. If you don't understand the value of money, then how can you value other goods and services? So let's talk about value of money. What are the different values of money? So the first type of value will be face value. Now the easiest way for me to explain what a face value would be. So when I say 100 rupee note, this is a promise that I will give you 100 rupees, right, by the governor. So this becomes the face value, correct? 100 rupees is the face value of this money. So almost every contract will have some face value. Some value would be given to on that contract. Okay. This is also sort of a contract which has the face value of 100 rupees. Then we can have market value. So when I say $1 is worth 80 rupees, that becomes the market value. That means my 80 rupees can be exchanged for $1 in the open market. That becomes the market value. Okay, so we have face value, we have market value, but here we are more worried about time value. Now time value of money is the value of money that changes with time. Okay, time value of money is the value of money that changes with time. Now in a way market value does also change with time. Now maybe tomorrow you will see 81 rupees for $1, maybe day after tomorrow you will see 79 rupees for $1. Right. So market value keeps on changing, but the reason of market value changing is a lot of different, it changes because of a lot of different reasons, and that is not part of our course. The time value of money that we are talking about is the value of money that changes due to two factors. One is interest and the other is inflation. So in this course we are worried about time value of money that changes due to interest or inflation. Now for interest we have chapter 4 and 5. We are going to study time value of money that changes with interest in chapter 4 and 5, and inflation we are going to study in chapter 6. So we are saying time value of money. In this chapter we are worried about interest. Now I think everybody has learned simple interest and compound interest. Right? Now if I say simple interest, SI is simple interest. So how do we calculate? We say principal amount into rate of interest into time. That becomes the simple interest. And if I say how much is the accumulated value, AS, because we are talking about simple interest, we'll say it is principal into 1 plus IT, because it is principal plus the interest. When it comes to compound interest, we first calculate the accumulated value. We'll say principal into 1 plus I raised to n. That is the amount that we'll get after n years. And if I want to calculate compound interest, I will say it is this accumulated value minus the principal amount, and that becomes the compound interest that we can calculate. Now I've used here T because it's easy for us to convert simple interest according to whatever unit of time we have. That means if simple interest, I write it as IS, is let's say 6% per annum per year. This will be same as 3% per half year or 0.5% per month. These will all be equal and they will give you the same amount in the future. Okay. And the time, that is T, here we will take per annum. So if let's say we are talking about 2 years, so you can take T as 2, or you can take T as 4 half years. 2 years have 4 half years, or you can take them as 24 months. So you can have time according to whatever unit of rate of interest is. You can convert one into the other. But when it comes to compound interest, we take n as number of years and I as per annum rate of interest. Rate of interest in terms of per annum and n as number of years. Now what happens if rate of interest is not in per annum, if it is monthly, if it is half yearly, if it is quarterly? That we'll study in chapter 5. In chapter 4, we are going to assume that a rate of interest is yearly. Okay. So let me just make up a question. I hope you have your books, everything ready. And I'll make up a question for our simple interest and compound interest so that we can quickly understand it. Okay, just give me 1 minute. Write down this question. Now we will require a scientific calculator for calculation. So if you are going to give the examination from IAI, that is Indian Institute, okay, Institute of Actuaries of India, then I recommend you buy Casio FX 82 ES Plus. This is the calculator that you should buy. If you are giving the paper from IFOA, there is no restriction in the calculators. There's no restriction in which calculator you can buy, but I recommend you buy Casio FX 991 ES Plus. Okay, for both of them, it is very important that you buy the ES version, not the MS version. Okay, there is another MS version. Okay, but do not buy the MS version. Please buy the ES version. It's very important. Now, there is no calculation in throughout our course that you cannot do in 82 ES Plus, but there are a few advantages of buying a 991. That is because there, you can do a few equations can be solved easier in 991 than you can do integrations. Now all of these you will have to solve on paper as well, but it helps to check if you have the calculator in which you can do integrations and stuff. Okay, in 82 ES Plus you cannot do integrations, you cannot solve simultaneous equations, you cannot solve quadratic equations, you cannot solve cubic equations directly. In 991 you can do that, you can solve integrations, you can solve quadratic equations, you can solve cubic equations, you can solve simultaneous equations, okay, directly in your calculator. Okay. So there is a slight advantage, but it is not a big deal. The things that you cannot solve on the calculator, we'll see how to solve it on paper directly, right? So this is my recommendation. Now, even if you have never used a calculator, don't worry. Okay, I hope you have used even the basic calculator. I think you have already familiar with. But if you have never used a scientific calculator, don't worry. We are going to learn that throughout our course. So first of all, if you are downloading an app to simulate the calculator like I have done here, make sure that the app has the 4 arrows. You can see here 4 arrows. That is very important because let me just show you. See, this is the old version of the calculator and this is the new version. And it does not matter which one you take, even if you have the old version, it will not be a problem. I think the only thing that they have changed is how it looks. I have not found anything that is different in the calculator, but you can see that we have 4 keys here. This is called as navigation keys. 4 keys here as well as 4 keys here. These are very important for us to make the equations. So that is why if you are downloading an app, search for scientific calculator or search for FX991 and you will find many scientific calculators, but only use the one that has these 4 arrows because it will be good for practice purposes. But do buy the calculator as soon as possible so that you can practice on it. Okay, the more you practice, the faster you will get on the calculator. Okay. Now the 82 ES plus will also look almost the same. I'll show you. Just colors are slightly different. Okay, so this is how the old 82 ES plus used to look. Again, the layout is almost the same. So we'll study from one. And okay, Tajpai, you are asking II allows FX MS 82. Yeah, 82 MS you can use, but I am telling you buy 82 ES, because there will be at least one function that is present in ES that is not present in MS, and we require that. So please buy ES. And this is the new version. They call it as second edition. Again, not a big difference in any functions, only the look has been changed. So even if you are buying the second edition, it's fine. If you have the old one, that is also fine, no problem. Okay. But make sure that you are buying the ES, not the MS version. So throughout our course, we are going to learn how to use the calculator. So I'll just give you a basic rundown. You have your basic numbers, multiplication, division, addition, subtraction, that we all understand very easily. Delete is for deleting anything you have written wrong. AC is to, get a clear whatever this is. Okay. Then these are the additional keys. Okay, so these are the special keys that are used in the scientific calculator. Most of them you will understand very easily. This is root. This is for fractions. This is square. This is for any other power than square. Okay. You have log. This is log to the base 10. You have ln, that is log to the base e. If you want any other base, you can see this is the log. X raised to minus 1. Then you have a key here for integration. We'll talk about that later, not now. These are not really useful. Okay, because we are not going to study trigonometry. So this hyper, sine, cos, tan is of no use. This is minutes, seconds and stuff. I have never used it. I don't know how to use it. If you want to learn, okay, these are degrees and minutes and seconds. Okay, so I don't know how to use it. You can see two brackets. These are going to be important. Okay. Then RCL is important. We'll learn about that later. And this is going to be important. So you can make a very complicated equation in your calculator. Okay. So let's say if I have let me just let's say this is the quadratic equation that we have, or I'll just make a little bit complicated quadratic equation. Okay. And I want to solve it. We know the method, we know the formula, minus b plus minus b square under root of b square minus 4ac upon 2a, right? So accordingly, I will have here minus 6 plus minus under root of 6 square minus 4 into 3 into 2 upon 2 into 3. What we can do is we can very easily make that equation in our calculator directly. So first of all, I will use this fraction button to get a fraction here. Then in the numerator I want minus 6, and we cannot have plus minus together, so we'll have just minus first, minus, then under root. So under root 6 square, I can use square, or if I want any other power I can use this as well. So these two buttons, so I'll just use square, minus 4 into 3 into 2. Now I have to come out of it and go to the denominator here. So for navigating our equation, we are going to use navigation keys. Okay, we are going to use navigation keys. These are the 4 keys. So I will come out and then go down. So you can use for that side arrow key or down arrow key. Both will work, no problem. So side arrow, I will come out of the root and I want to go down arrow key. So now we are at in the denominator. You can see the cursor is in the denominator. 2 into 3. So this way you can make a complicated equation directly. Now in your physical calculator, most likely the answer that you will get is going to be in a fraction form. Okay, this is how, okay, this is not exactly fraction form, but if it is possible, they will write the answer in fraction form. Okay. Then if you want to convert your answer from fraction form to the decimal form, this is the SD button. This converts your fraction into decimal, decimal into fraction. So if you press this SD, you will change the answer from fraction to decimal and decimal to fraction. So this is one of the answer. Now I'll press AC. Now I want to use the second equation with plus. Rather than making the same equation again, what I can do is I can use the previous equation. So if I press the up arrow key, I can get to the previous equation. Now I think up to 10 equations are stored in our calculator. So if I keep on pressing up arrow key, it is going to show me the previous equations that I have been using. So these are all the previous equations that I have been using. Now I don't want to, I just want this equation. I want to edit this equation. To edit this equation, I'll press the side arrow keys. So when I press the side arrow key, you can see I get the cursor and I can delete this minus and add a plus there. So you can clearly see that we can use the equations in such a way. We can make very complicated equations in our calculator. Here we have quadratic equation solution. Now there are more special characters that we can use. You can see here stuff are written in yellow and stuff are written in purple. Anything that you want to access written in yellow, you will press shift and then press the button. Okay. So let's see here, you can see x cube is written in yellow above this x square button. So if I want, let's say 3 cube, I will press shift and then I will press the x square button and you can see now I have the cube. So whenever I want to access anything written in yellow, I'll press first shift and then the button and I will get the what do we say, the things written in yellow. So like you can see here, I have a factorial that is written in yellow above x raised to minus 1. So if I want to find what is 6 factorial, I'll press shift 6 shift and then x raised to minus 1 button and you can see I have 6 factorial. That gives me 720. Then if we want to use anything written in purple, there are stuff written in purple as well. We are going to use them later. We are going to press alpha and then press that button to get anything written in purple. So this is how they have made a lot of different kinds of functions that you can directly use in your calculator. Okay, and as we go along, we are going to learn more and more. So I'm hoping that you buy the calculator as soon as possible so that you can practice yourself. I hope you have written the calculator names. Let's go to this question. So we have an investor invests 500 in two accounts, each for 4 years. Find the amount he will have if the account A pays simple interest of 7% per annum and account B pays compound interest of 7% per annum. So first, let's talk about account A. Account A has simple interest of 7% per annum. So if we want to directly find the amount after 4 years, so in simple interest, we'll just say principal amount is 500 and 1 plus the rate of interest is 7%. See, 7% is same as 0.07. Okay. Whenever we are writing something in percent, that means it is divided by 100. Okay. Percent just means per 100, that is divided by 100. So it is actually 0.07. So by any chance in 11th 12th you have studied that we write I by 100 or R by 100. Don't do that. Okay, we are not going to do that. We are just going to write I, that is also 7% and also 0.07. So same thing, we don't need to write upon 100 for it. Okay, so 1 plus 0.07 into the time is 4 years. So make sure that you have the same unit per annum and here years. So I have 640 here. Now I'll also solve account B. Compound interest given here is 7% per annum. So accumulated amount or the amount that you will have after 4 years. So in the calculator, 500 into 1.07, I want raised to 4. So I will select this x raised to bracket key here. And now you can see the cursor is on this bracket. So I will have to put 4 and then equal to. Okay. Any problem here? Now we understand how simple interest and compound interest works. But can you tell me, why do we have two different rates of interest? Why do we have simple interest and compound interest? Why not just study one? Why are we studying two different rates? Can you tell me which one is used most of the times?
Compound
Yes.
interest.
Yes. So most of the times we use compound interest, but sometimes we use simple interest. Right. Now, how do we differentiate between when to use compound interest, when to use simple interest, or why do we need two different ways of doing the calculation. Why not just one? This interest is not some physical quantity or law of physics or something that we cannot change. This is a made up thing. As we said, money is just a concept. It's a made up concept to felicitate our own life. So the simple interest and compound interest are just ways of understanding how money is changing with time. But then why do we need two different? Why can't we just learn one? Anyone? Anything that comes into your mind. Don't worry. There's no reason for you to not say anything. Because even if you're not correct, it does not matter because you're learning. See, it is a very famous saying that if you are not wrong, that means you're not learning anything. Okay. If you know everything, if you're always correct, then you know everything. You don't need to learn anything. Here we are to learn new things. So we are supposed to be wrong. If you're not wrong, then you know everything. Then, I cannot teach you anything, right? So here we don't, feel like I might be wrong. Does not matter. That is how we learn. So anything that comes into mind, we all have studied simple interest and compound interest. Why do we study two different? Why not just one? And then use that one every single time. Now we know most of the times we use compound interest. That is the fine. But anyone, can you come up with anything that comes into your mind? At least from this question that we have solved. The rate of interest was exactly same. Right? Rate of interest was exactly same. Invested for same number of years. The amount that was invested was same. But still we had two different answers. If we had one single answer, then it would have been fine. It would have been two different methods. Okay, Mohammed, you're saying different types of investment. Yeah, but why do we need different kinds of investment? Why can't there be only one kind of investment? Now, can you tell me which one would you choose? Let's say you had 500 rupees to invest in account A or in account B. Which one would you choose? Account B, right? Is there anyone who would choose account A? Is there anyone who would choose account A? I don't think so, right? Clearly because you're getting more money in account B, so everybody is going to choose account B. So even if I offer you two options of investment, account A and account B, everybody is going to choose account B and there is nobody who is going to choose account A. So then this kind of investment just goes away. Correct? So the reason is not different types of investment. Anybody else? Now, usually people say that because in compound interest we earn more interest. That is why we'll choose account B, and that is why we'll choose compound interest and not simple interest. Now, that is not the main reason. Okay, we study two different rates of interest is not because compound interest has more interest, because if somebody is giving you interest, they have to pay out of their own pockets. Like you gave them 500 rupees, they gave you 655 back. So whoever is lending money is getting more money in compound interest, but whoever is borrowing money is actually have to give more money back. So the borrower would prefer this and the lender would prefer this. That makes sense, right? Borrower would prefer to give less interest and lender would prefer to get more interest. So if I am giving you money, you will ask for simple interest, but I would prefer compound interest. That makes sense, right? So we'll never come into the same agreement. You would say I want simple interest, I would say I will give you compound interest, and we'll never come into same agreement. So that is not the reason. It's not about interest. We both have to come to an agreement. Only then the contract will work. So it's not about, again, simple interest, compound interest. It's not about how much interest are you getting. But compound interest is consistent. We'll learn later on what does this consistent word means. But what happens is, even if I invest for small number of years or a large number of years, the compound interest would give me the same answer if I'm investing for the same time period. Okay, so I'll just show you a simple example. Let's say that you are lending me money for 3 years. Okay, you are lending me money for 3 years. You gave me 100 rupees today, and the rate of interest that you're charging is simple rate of interest of 10% per annum. So after 3 years, how much will it be? So you'll say 10% per annum or 100 rupees, that is 10 rupees per year. So in 3 years, it would be 130. Correct? So you gave me 100 rupees today. After 3 years, I will return you 130 back. That makes sense? Similarly, you gave the money to someone else. Okay. Or let's say I take that money, I take that 100 rupees and lend it to somebody else at the same rate of interest. At the same rate of interest. But I lend it only for 1 year. I lend it for only 1 year. So I took that 100 rupees from you and I lend it to somebody else for only 1 year. So after 1 year, I should get 110 rupees back. So I got 110 rupees back. I took that 110 rupees and then lend it to somebody else again for 1 year at the same rate of interest, that is 10%. So again, I am going to lend it to somebody else at 10% rate of interest. So after 1 year, they are going to give me 10% interest on 110, that is 11 rupees. So I have 121 after 1 year. And then I take that 121 rupees and lend it to somebody else. Again for only 1 year. Again for 1 year, 10% interest on 12.1, 121 is going to be 12.1. So the total amount that I will receive is going to be 133.1. So I took your 100 rupees, gave interest the same rate, okay, exactly same rate of interest, and I made a profit out of it. You can clearly see I will give you 130 back and keep 3 rupees, 3.1 rupees as profit. Does that make sense? Now you would say, why would I not just do the same thing? Why am I giving loan for 3 years? I will give loan only for 1 year. If you want the loan for 3 years, return me money after 1 year and then take the loan back as soon as at that same time only. You would say that after 1 year return me 110. If you want loan for one more year, take that 110 and then return me 121, and then immediately take that 121 back and return me 133.1 after 3 years. Correct? You would prefer this because it's clearly earning more profit. Now, if I am a businessman, if I am running a factory with this 100 rupees, you can imagine after 1 year, I may not have that 110 rupees at that time. It may be, a lot of raw material and everything I bought out of it. I don't have that 110 rupees just to give you so that you give me back 110 rupees. So it will be very inconvenient for me to give you 110 rupees back so that you give me 110 back for the same thing. So what I would say is, rather than taking 130, just take 133.1, but don't ask me to repay you the money again and again every single year. It's not convenient for me to do that. Correct. Now, in that case, this calculation is actually compound interest. This is calculation using compound interest, because what is happening here is the difference here is that each year the interest was taken always on the principal amount, whereas this 10 rupees as interest also earned interest here, and this 1 rupee is basically the interest on that 10 rupees. And this 21 earned interest here, this extra 3.1 rupees is due to that 21. So you're earning interest on interest as well. That is what our calculation of compound interest does. So if I had 100, 1 plus I raised to 3, that would be 100. 10% would be 1.1 raised to 3. You can see 133.1. Now actually, if in compound interest you directly calculate for 3 years, or you calculate this one by one, okay, one by one, you will always get that same answer, that is 133.1. You will always get the same answer, that is 133.1. Whereas in simple interest, we just saw direct calculation gave me 130, whereas yearly calculations gave me 133.1. So simple interest is not consistent, whereas compound interest is consistent. Okay, simple interest is not consistent, whereas compound interest is consistent. So that is why compound interest is used for large amounts of money and for long periods of time. For large amounts of money and for long periods of time, this difference Here we might say the difference is just 3.1 rupees, but for large amounts for long periods of time, the difference will be larger. So that might be significantly much higher. So for large amounts of money and for long periods of time, we are going to use compound interest. But what about simple interest? Why do we still study simple interest then? We understand compound interest is better. For small periods of time and for small amounts of money also we can use compound interest. Then why are we using simple interest? Why are we learning simple interest? We should not even learn the simple interest, right? Now we study simple interest because as the name suggests, it is simple for calculation purposes. Now if you saw here, when I was doing calculations of simple interest, I did not actually need a calculator. I just said, okay, 10% interest on 100 rupees would be 10 rupees per year. So for 3 years, it becomes 30 rupees. Right? The calculation was very straightforward, very easy. Whereas for compound interest, I needed a calculator because maybe you might say, I know what 11 cube is, that is 1331. So then it is very easy for me to do the calculations. But you can imagine that if I had 7% here, I could still do very easily calculation. 7 into 3 would be 21. The calculation for simple interest would be very easy. But if I had here 7%, I would have 1.07 raised to 3. And 107 cube, I don't know. I can, it will be a very difficult calculations without using the calculator. So for compound interest, the calculations are very complicated. It requires the assistance of calculator, whereas simple interest, most of the times you would not need any calculator. You can do mental calculations. It's easier for people to understand. If I say 10 rupees interest per annum, every year you have to give 10 rupees, so in 3 years you would say, okay, 30 rupees interest, right? If I say 10 rupees interest per annum and in 3 years you will get 30 rupees, right, per 3 years. That is easy for us to understand. Whereas if I say 10 rupees per annum and 33.1 per 3 years, that is what we are seeing here, or also in compound interest. Correct. So it's difficult for us to imagine. We understand this because we understand how calculation, how compounding works. But for a person who is illiterate, for a person who is, does not have much experience in mathematics, it will be very difficult for them to justify this in their head. Correct? So for small amounts and small periods of time, simple interest is used because it is simple for calculation. And the difference, so when we say simple for calculation, maybe for 2 years, maybe for 1 year, maybe for a half a year, the difference in the interest will not be a very big amount. It will be a very small amount because amount is also small. The time of calculation is also small. Okay, Tajbhai, you are asking which matters in under consideration to fix the interest. I did not understand. Could you rephrase the question? That is why most of the times you are going to see compound interest, but still we are going to see simple interest sometimes. Okay. It's comparatively less, but it is still present. Simple interest is still present. So any other question? Tomorrow we are going to continue and we are going to study more. Today I don't want to start a new topic so that we'll not have enough time for it. Now, so today, if you are sure that you are going to study actual science, then the calculator is very important. So as I said, for IAI, Casio FX 82 ES plus. For IFOA, Casio FX 991 ES plus. Make sure both of them are ES and buy the calculator as soon as possible uh, because the practice matters a lot. Okay. Okay. So any other question? Now tomorrow our lecture is going to be 12 to no, tomorrow it's going to be 1:30 to 3. Okay. So our lecture is going to be 1:30 to 3 p.m. and we are going to continue this tomorrow. If you have any other question, you can ask me or you can call the office. Okay, so office number is present down here. You can call us and ask for anything, and we are going to discuss tomorrow a lot more things. Okay, the timings of our classes, the fee structure and everything. You can ask me tomorrow. Okay, so let's end the class here today. We'll meet tomorrow.